our senior design project at Utah State University is the PLUGSY Automated Gardening System, and which is an acronym that stands for the Planting and Landscaping Utility Gardening System for You. Although gardening is a very popular hobby, it is also labor intensive and time intensive, commodities which often people do not have. Often they may be disabled or have a busy work schedule and are not able to grow those fresh vegetables that are so hip with the kids. So we wanted to automate many of those tasks, and which brought about the PLUGSY Automated Garden.
So our PLUGSY system, it's kind of, if you can imagine, a 3D printer for your garden. It's a gantry type system which can attach to any standard size 4 foot by 8 foot garden box. Has 2 long rails running down the length of the garden, which then have 2 little carts attached to those. Attached to the carts are some vertical extrusions, which then connect a crossbar over the top, which holds the implement arm. So as you can see in some of these still photos, like I said, stepper motors are used mainly to move about the garden. So with the stepper motors in the X direction, the Y direction, and with a linear actuator, we achieve all 3 degrees of motion, X, Y, and Z. First task that our PLUGSY can accomplish is planting. The way it does this is using the rails and the carts and the linear actuator like I just described. It can maneuver to any point in the garden, and then it will be able to go down into the soil and deposit seeds there. As well, the system can be programmed, like I mentioned, to plant anywhere in the garden. As well, it can remember where you planted, so as to better be able to implement the watering system.
Our watering system starts with capacitive soil sensors. These long-life sensors are placed in each quadrant of the garden box. They measure how much moisture is in the soil, so once it starts to get dry, it can send a signal to a water pump. We have a water reservoir mounted on the side of our garden box with a water pump inside. When it detects that there's a low amount of water content in the soil and the plants might be a little thirsty, it activates the water pump, which sends water through a hose down to the Z-axis on our gantry, which then can water that area of the plant, giving it all the life-giving water that it needs. In any healthy garden, particularly if you're giving it care with water and all the things that it needs, weeds will start to crop up. So we decided we needed some kind of weeding system to take the arduous task of weeding out of the gardening process. Our weeding implement, which you may notice is just a tent stake, is meant to be a spike, which stabs into the ground, cutting the weeds in pieces and mashing them into the ground. Doing this continuously will deprive the weeds of sunlight and needed nutrients and cut them off from their stems, which slowly kills the weed. It's not the most efficient method, but it's really easy on motion, which is great for our gantry system.
So as you can see, we successfully automated the planting, watering, and weeding functions in the garden. However, there were a few things that we initially specified but weren't able to fully implement, such as a user interface that was more user-friendly, weed detection using computer vision or artificial intelligence, and full support for other species, many species of plants that you can grow in your garden. We also, as a final dream, wanted to implement a fully automated salad maker that would grow, water, weed, and harvest a salad and finish it in a bowl for you.
So over the course of this project, we definitely learned a ton. As the 3 of us were all computer engineers, there was a lot of mechanical design legwork that we had to put in first, just to get the gantry constructed and up and running before we could even think about programming it. Another thing that we had a lot of fun with was with the electrical design and electrical management. You can think of that as cable management, to make sure that we didn't just have a big rat's nest, as it were, of electrical wires and cable. We had to think of really good ways to make sure all of our power supplies and our signals wires were managed really well. As well, something that I don't think any of us had much experience with before, we had some but not a lot, was hardware debugging, which we found out was a lot more difficult than software debugging. Software, you get a nice little error message if your code doesn't compile, but if your motor isn't working, it doesn't really give you an error message as to why. I think the biggest thing that we learned, and the most important and useful thing that we learned, was in planning our project and planning and making it so that each part of it would be modular. That is to say, like the motors were one module of our project and the watering system was another module. That way we could, work on that specific part of it, get out any bugs of that system, and then integrate it with the rest of the system.
We get it. Gardening is hard. There's all the planting, watering, and weeding that you have to keep track of constantly. And if you don't, your plants die and you don't get your veggies. But for those of us who don't have that kind of time, or maybe just aren't quite that proactive, the PLUGSY is here to help. The PLUGSY, plugging plants into the ground and food into your mouth.